Okay, in this chapter we're going to look at measures of centre and spread. So we can, measure of centre is two options. It's the mean or the median, and then we have the spread can be either the range or the IQR. So we've already had a look at these, but we're going to have an in-depth look at them now. So the median is the midpoint of the distribution. So when we have all our data, if we broke it up into two halves and we split it in half, the median would have 50% of the data occurring before the median and 50% of the data occurring after. So it's a measure of centre, and it is a resistance statistic. So it's not affected by outliers, because even if we have this little extreme outlier out here, we are simply ordering the data and finding the middle number in the middle of the line. So the outlier doesn't affect the median. So how do we find the median? Is we can find the median using this formula. So here, the n+1 divided by 2. So this is how we find the median in a set of data. Okay, so it just tells us the position it is. So when we have an odd set of numbers, so when n is odd, so if we had say 23 in the data set, the median will be the middle number. So let's put in a little example for that. So say n equaled 23 here. So what we'd have is that we'd have that the 12th value would be the median, and what we'd actually have 11 data before it and 11 data after it. So you could see 11 plus 11, that's 22, plus this 12th one would make 23. So that's how that one works when you have odd number n. If you have a even number n, so let's do an example, say n is 40, the median will be the average between the two numbers. So if we split 40 in half, we'd have 20 and 20 here. So really what we say between the 20th and the 21st value, that's the number in between that is the median for the even. We'll see in our examples anyway. All right, so the dot plot opposite displays the age distribution of 13 members in a cricket team. So you know n equals 13. Now it says determine the median. So we know that the median is found at n+1 divided by 2 position. So we're going to say 13 plus 1 divided by 2. So it's the 7th value is the median. So what you're going to do, you've got to start at the lowest and you start counting up. So that'd be 1, 2, 3, 4, 5, 6, 7. So the 7th value is 22. So 22 equals the median. Okay, so the stem plot opposite displays the maximum temperature of 12 days. So we know n equals 12. Determine the median. So we know the median can be found at n+1 divided by 2. So we go 12 plus 1 divided by 2. So we end up with the 6.5 position. So this is because it's an even number. So therefore, we know it's between the 6th and the 7th value. Okay, so we've got to go through and find them in our data. So if we go through, we go 1, 2, 3, 1, 2, 3, 4, 5, 6. So 25 is my 6th value, and 27 is my 7th value. So the number in between those two would be 26. So 26 ends up being the median of that data. Okay, the body mass index in kilograms per square metre was recorded for a sample of 32 men. So they told us N, but they've written it there anyway. Describe the shape of the distribution. So because we have lots of data at the start and then it tails off, we're going to say that is positive skewed. And the next question, it says determine the median. So we find the median at n plus 1 divided by 2 position. So it would be 32 plus 1 divided by 2. So it ends up being 16.5. So it's an even number, so we know therefore it's between the 16th and 17th value. So we're going to have to count up that thing. So I'm going to count through. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So here's the 16th, and that would be the 17th. So the 16th value was 24.5 and the 17th value was 24.6. So the number in between those would be 24.55. So we see the median is 24.55. Now you could enter the list in and get your statistics through the calculator, but to enter in 32 numbers and then go through the steps to get the median, it's a lot. It's probably quicker doing it manually. Okay, so here we've got a histogram with a log scale. So just remember what we learned about log scales, that this simply, if its actual number is 10 to the power of 2, which is 100. So that would a 2 on this scale represents 100. Okay, so the percentage of craters that of less than 1 kilometre. So this 1 kilometre is an actual number. So if we want to convert it to a log, remember we can go log 10 and we put the number in there 1 and it will equal 0. So this number here represents a 1 in real, like as a real number. So we want to know how many is less the percentage. Now remember, percentage is the amount over the total times 100. So we have not been given how many is in total. So we're going to have to add them up. So we've got 1, 1, 7, 4, 4, 4. So if we add all those up, we get the total to be 21. So we now know it's out of 21. Now they want to know what's less than 1. So that was this point, so all the way back that way. So we want the 4, 4, 1, 1. So we end up with 17, and then we times it by 100 to get a percentage, and we end up with 81%. See. So here now, they want us to find the median. So we can still do it on a histogram or frequency. All we have to do is find where it occurs. So we already know that n equals 21. So we know that the median occurs at n plus 1 divided by 2. So this one would be 21 plus 1 divided by 2. So it happens at the 11th spot. So what you're going to do is start at the start and go through the frequencies, adding them up until you get to 11. So here we've got 1, and if we add another 1, we're at 2. If we add another 7, we're at 9. And then if we add another 4, we would be at 13. So what it means is the median occurred somewhere in here between this category. So we know the median happened between a log of -2 and -1. So we know if you convert them to an actual number, log -2 is actually 0.01 and -1 is 0.1. So we're looking for a number that's between there. And if you have a look, or we'd say the median occurs somewhere between that category. So it'd be this answer here, B. Okay, a group of students were given a comprehension test in which each received a mark out of 50. The results are displayed in the histogram. So the median mark would be obtained closest to. So we know that the median is found at n plus 1 divided by 2. But we don't know what n is, so we're going to have to calculate n first. So n, we can add up all the frequencies. So I'm going to do that first. So if we look, we've got 1, 4, 8, 12, 14, 15, 12, 7, 4 and 3. So if we add all these numbers up, you'll see that we end up with n equals 80. So we know that's 80. So therefore we can find the median at 80 plus 1 divided by 2. So that means at the 40.5 position. So we are going to try and get to the 40th frequency, or the 40.5 frequency. So we're looking for that. So if I count along and if I do a running total, so here that would be 1 plus 4 is 5, plus another 8 is 13, plus another 12 is 25, plus another 14 is 39. So then if you add another 15, you get 53. So we know the median is occurring in this, somewhere in this bin or tower, and we can see that that one is between 25 and 30. So there's only going to be one number between 25 and 30 in our answers. So the median occurs between the 25th, the 25 to 30 mark. So if you look, the D is the only one in that category. So that's our median. Okay, the histogram shows the marks for 52 students. So it's always nice when they already give us the N. The median mark, so median's going to be found at n plus 1 divided by 2. So we've got 52 plus 1 divided by 2. So it's going to be the 26.5. So we just need to count along the frequencies again. So if we just added them in along here, 6, 7, 8. So we want to get to the 26. So if we go along and we add them up, we've got 1 plus 2, that would be 3, plus another 3, that's 6, plus another 3, that's 9, plus another 5, that makes 14, plus another 6, that makes 20. And we want to get to the 26.5, so we get to here and there's 27. So it's going to occur somewhere in this column, so it's somewhere between 30 and 35, which is C. Okay, here we're looking at the range. Now we're talking about the range, which is a measure of spread. So the range is the maximum value minus the smallest value. So the range is affected, affected by outliers. So it's not a very good measure of centre with skewed or outliers. But anyway, so if we have a stem and leaf plot and we've got to get the range, we simply just go and get the maximum. Here's the maximum value and here's the minimum value. So the range would equal 33 minus 18, which equals 15. So the range is 15 there, 15 degrees if we're talking about what we're talking about. When you have a histogram as shown and you need to find the range, you simply go to the lowest one it can be. So that's the minimum and 100 is the maximum. So the range on a histogram, if this is the only data you have, would be 100 minus 10, which would equal 90. Okay. Okay, the next thing we're going to look at is the interquartile range. So the interquartile range is the third quartile minus the first quartile. And it is a resistant statistic because it's not affected by those outliers. So it is a good measure of centre, especially when you have skewed data or outliers. And it measures the data around the median. It pretty much tells us, it shows us where 50% of the centre data, the middle data, 50% of the middle data. So what if you're saying, because obviously if you had your data broken up into quarters, so Q1, now Q2 is actually the median, yeah, and then you have Q3, and then the finish would be Q4. So if you're finding the interquartile range, which is this is the middle 50% of the data lie between that. Middle 50% of data is in there. Okay, so the way to find the Q1 and the Q3 manually, so if you're not putting it into a listen spreadsheet, is that you can see that the Q1 is actually the first, it's the median of the lower half. So if I just do this data again, and I broke it, you broke it in half, there's the median, you can see that Q1 is actually the halfway mark of the first half, and Q3 is the halfway mark of the second half. So we can split the data in half and then do the same method as we use for the median. Okay, so why is the IQR more useful spread than the range? So it's because it shows the middle 50%. The outliers would be always out in these things. So they can sometimes distort. So the IQR shows the big chunk where most of the data is, and that's why we use it. So it's not affected by outliers or skewed data. Okay. So here when we want to do it without having to enter this whole list into our calculator, we want to find the interquartile range just manually. So first of all, we know IQR is Q3 minus Q1. So the first thing we're going to do is we look for, and they told us we had 18 cats, so N is 18. So if you thought about, if we split the data in half, we'd have 9 data points at the front and 9 data at the end. So we can really say N equals 9 in the first half. Okay, so if you were finding the median of the first half, you'd say N plus 1 divided by 2, so it'd be 9 plus 1 divided by 2, so it's the fifth. So the fifth value of the first half is the Q1, and so let's go through that. So we've got 1, 2, 3, 4, 5. So 2.8 is Q1, so that was Q1. Now you want to go, because we have 9 in the second half, it'll also be the fifth from the end. So you can just count backwards to get the Q3. So we can go 1, 2, 3, 4, 5, and it's 4.8. Okay, so then we can work out the IQR is 4.8 minus 2.8, which equals 2.0 is the IQR. Okay, let's practice that again. So the STEM plot shows life expectancy in years for 23 countries. So N equals 23. So here we've got an odd set of numbers. So remember, we've got, if we have our data broken up, we would have 11 data here. Our 12th one would be our median, and then we'd have 11 data in the second half. So this here essentially is our first half, and this is our second half. So once we've split it in half, we can then find the median of the first half. So the median of first half would equal n plus 1 divided by 2, which equals 11 plus 1 divided by 2. So it's the sixth. So if we go in from the start 6, so 1, 2, 3, 4, 5, 6. Here's the sixth value, and that's obviously our Q1. So Q1 equals 66. Now we can do the same, but we want to go in from the end sixth. So 1, 2, 3, 4, 5, 6. So we get Q3 is 75. So the interquartile range equals 75 minus 66, which equals 9. So that's just a manual way. You could type this in lists and spreadsheets if you wanted, and just put the whole lists in and get the IQR. If you've got lots of questions on the same data, you're probably best doing that. So you write 52, 55, 56, blah, 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 and you put a list in and do your stats on your calc. Okay, so here it says they want us, we've got the average number of hours worked for 23 people. So we know n equals 23, and they want us to find the median and the quartiles, so which is Q1 and Q3. So just going back, it's similar numbers to what we said before. If we have n equals 23, well, the median would be at the 12th, and there'd be 11 data here and 11 data here. So the median happens at the 12th. So we could go and find that. If we add up all the frequencies, we've got 1, 2, 4, 5, 6. Sorry, I missed this one, which was 3 and 2. So the median is at, let's do the median, is at the 12th. To be 1 plus 2 is 3, plus 4 is 7, plus 5 is 12. So the median definitely occurs in here. So possible values for the median. So the median occurs between 60. Well, we're gonna, because we hit right on 12 when we add this 5, we'll probably say it's between 60 and 70, but it's probably the 70th one. Then we want to find, say, the Q1. Q1's going to be, again, the sixth one in. So if we go like this, we had 3, and then we add another 4. So that would be 7. So we know Q1 occurs in this one. So Q1 occurs somewhere between 50 and 60. And then we can go back 6. So 2 to there is 8. So somewhere in here is the Q3. So Q3 occurs somewhere between 80 and 90. Okay, the ordered stem plot shows the maximum temperature in degrees on 15 days. So we've been told that there's 15. The value of the first quartile, Q1. So remember, if it 15, we would have the median occurring at the 8th. Okay, and then we would essentially have 7 data before it and 7 data after it. Okay, so therefore, remember Q1 is the median of the first half. So it means we'd have 7 plus 1 divided by 2. So we're going to get the fourth value. So we go 1, 2, 3, 4. So the 1, 2, 3, 4. So the Q1 is at the 12.2. Then it asks us the percentage of days with a maximum temperature of higher than 15.3. So once again, whenever we see percentage, you know it's the amount out of the total times 100. So because they said of all these days, we know it's 15. Now how many are more than 15.3? That's 1, 2, there was 3 of them, and then we times by 100 and we get 20% is our answer. I think we actually have done this question earlier, but we're just going to do it again. So the range for these test scores, so here's max and here's minimum. So it's 89 minus 40, so we get 49 is our range. And then it wants the interquartile range. So let's just practice what we said. We know interquartile range is Q3 minus Q1. So if our data is 23, so once again we're going to see the 12th would be the median, and then we'd have 11 data before it and 11 data after it. So Q1 will be the median of the first half. So it would be 11 plus 1 divided by 2, so it's going to be the 6th. Okay, so we count in 6, so 1, 2, 3, 4, 5, 6. So Q1 equals 57, and then to get the Q3, we just go back 6. So we go 1, 2, 3, 4, 5, 6, which is Q3 equals 75. So then we just do the interquartile range is 75 minus 57, which equals 18. Okay, in this one, the histogram, we've got 252 men, so N is 252. They want the Q3. So if we split the 250 in half, so the median, 252, we'd have 126 data here and 126 data here. So we want the Q3, so the Q3 equals the median of the second half. So if we found that, so n plus 1 divided by 2 would be 126 plus 1 divided by 2. So it ends up being the 63rd.5 spot. So with the Q3, we start at this end, at the end, and we're going to go in until we get a frequency of 63.5. So if we add them all up, so say 6, this one's 3, I'm just going to put what's on top of them, 10, 10, 15, 23, 27. I'll stop there and see how we go. So if we're going to go and add them up, so we've got 6 plus 3, that would be 9, plus another 10, that's 19, plus another 10 is 29, plus 15 makes 44, plus 23 makes 67. So we needed to get to the 63.5. So what that means is we'll be there and it'll be somewhere in this column. So if we go down, it's going to be somewhere between 30 and 30.5. So we're saying Q3 is somewhere between 30 and 30.5. So there's only one number that is in between that range, and that's C. Okay, so when another measure of centre is the mean. So we might want to put the symbol for the mean, which is the X with the line on the top. And the mean is often known as the average in common terms. We call it average. And it's where you add up all the data. So you can see in the formula here when they say sum, so you're adding up all data, and then you divide by the total number, which is N. Okay, so it's not very good when you have outliers because that mean gets dragged towards the outliers, which we've discussed. And also not good when you've got skewed data as well. But the mean's good for symmetric data and to measure, and we use the mean to measure, we measure around the mean using standard deviation, which was SX, which is what we'll look into soon in the following lessons. So if we have this set of data, we're just to understand our formula here, or these symbols. So when we know N, that's the total number of data. So we would be we just add up how many people, or how many things we have. So here N is 8. When they say the sum of X, that means we've added all of those values up. And if you do that, the sum of x equals 335. And then the mean you would be found by going 335 divided by 8. So the mean ends up being 41.9. They actually, in your calculator, when you use the statistics function to find the mean, they also give you these two values as well. So once you've entered the list in, you can go find that in there. Okay, so just a refresh over which one to use, the mean or the median. So when we have symmetric data, the mean or median are fine, but we more commonly use the mean when we have symmetric data. When we have skewed data or with outliers, we generally use the median. We're going to use the median because the median's not affected by outliers. So if we have a look here, and if I highlight the mean in these things, so you can see when we have positive skew, the mean is actually higher than the median. So if I measured the median in green here, so you can see the median is lower. So you might write this in here just so you got the symbol. So the mean higher than median in positive skewed data. If you have negative skewed data, you're going to have a mean lower than the median. Okay, so and maybe we might write on here, this is positive skewed. We don't really write skewed. Positive skewed in general, and this one's negative skewed. So let's pop that up the top so we can see that. Okay, so in this scenario, the mean is lower than median when you have negative skew. And these two, in symmetric, they're the same. Okay, they're the same value, or close, or same or close in value. Okay, just to quickly go over standard deviation. So standard deviation will be found on our calculators in our summary statistics, and it's written as S of X, SX there, and it measures the spread around the mean. So we'll talk about it when we think. So we obviously use it a lot because it measures the spread around the mean. We'll use it in symmetric data. Okay, so that's when we'll symmetric data. Okay, so remember that's that bell shape. Okay, this is the formula for standard deviation. You don't ever have to manually calculate it, but they may get you to like cite it or know that that's the standard deviation formula. So we've just got it there. So once again, if you actually have to calculate it, we're just going to use our calculator. And here is how we do all our get our summary statistics. We've already done this a bit, but we're going to just go over it again. So you have your list of data. You go to list and spreadsheets. You label your list and you enter your list in, and then you press menu, statistics, stat calc, one variable. You then select your list that you want to do, and you'll get the following statistics. So here you can see is the mean. Down here is S of X. Now, before I told you, they do mention, so you can see here, there's mention of the sum of X. So you can have those values. Now, if you keep moving a bit further down, your summary statistics, you'll come into the 5-number summary, and which is important, but you can see there's the median, and you can also see Q1, Q3, things that we've been looking at finding manually so far.